Welcome. The sources you've pulled together for today are, well, they're just fascinating. They really map out how computers went from these enormous room-sized machines to uh, the intelligent partners we have in our lives today.
And that's the goal.
Yeah.
And for our exploration, we want to cut right to the chase. We're going to focus on three huge leaps: the integrated circuit, the microprocessor, and then the big one, artificial intelligence.
So the idea is to get a quick handle on how they got so small, so fast, and smarter.
Exactly. It's not just a story about speed.
Yeah.
It's really a story of accessibility and eventually intelligence.
Okay, so let's jump in with the third generation. We're talking, what, roughly 1964 to 71. The sources all point to one major breakthrough here.
The integrated circuit, the IC.
Right, so this is where instead of wiring up individual transistors, they figured out how to put multiple components on one tiny little silicon chip.
And the why that matters part is, it's not just that it shrank the machine. The key was reliability. Suddenly, these things didn't break down all the time from the heat.
Okay, so they were more stable.
Way more stable. And that meant businesses and universities could actually use them. You start to see machines like the IBM System 360 or the PDP-8 showing up.
And this is also where operating systems come into play, and those high-level languages like COBOL and Fortran.
Yes, and that's a crucial point. That shift to high-level languages was the first real step toward abstraction.
What do you mean by abstraction?
I mean, you could write code based on logic, business logic, scientific logic, without tying it to the specific hardware. The same program could run on different machines.
Ah, so it decoupled the software from the hardware.
It did, and that allowed the entire industry to scale up in a way that just wasn't possible before.
Which leads us, I guess, directly into the fourth generation, the microprocessor revolution, right? This is what moved the computer from the office into the home.
That's the one. The microprocessor itself, putting the entire CPU on a single chip, was, of course, the physical enabler. It just cratered the cost and the size.
But it was more than just the chip, wasn't it?
Oh, absolutely. The real shift was about user experience. When you get machines like the IBM PC or the Apple Macintosh, you have to completely rethink the interface.
This is where we get GUIs,
Yeah.
the graphical user interface, Windows, things people could actually, click on.
Exactly, and the programming languages had to keep up. You see C, C++I, and Java coming in to support these complex operating systems and apps. It didn't just make computers small, it made them usable for everyone and laid the groundwork for modern networking.
Okay, so that brings us to now, the fifth generation. And here the focus seems to shift completely. It's not just about getting faster anymore.
Right, the whole goal now is to get computers to think, to learn, and to decide things almost like a human would.
And this is where all the buzzwords come in. AI, machine learning.
And it helps to break them down. Think of artificial intelligence as the big, overarching goal making a machine seem intelligent.
And machine learning is how we do it.
Machine learning is the process. It's how we train the systems on these massive, massive data sets. And the structure that does the learning is often a neural network, which is loosely modeled on the human brain.
So you combine all that with something like natural language processing.
And you get things we use every day.
Yes.
Siri, Alexa, those chatbots you talk to online, even self-driving cars. This generation is about making computers intelligent partners, all powered by the cloud, and looking toward things like quantum computing.
So we've gone from these giant, unreliable calculators to personal tools, and now to these autonomous systems that are reshaping our world.
It's a remarkable path. The sources are pretty clear that this evolution is only accelerating. The integration of intelligence into everything is happening faster and faster.
Which leaves us with a final thought for you to explore. The sources point to a future being built on two huge pillars. As you think about this, which one stands out more to you? The rise of fully autonomous AI agents that can manage complex tasks on their own, or the development of widespread brain-computer interfaces? Something to think about.